Welcome to our comprehensive guide on monitoring and maintaining models, especially in the context of deploying and integrating data science solutions. As organizations increasingly rely on data-driven decisions, ensuring that deployed models continue to perform as expected is crucial. In this video, we'll explore the importance of ongoing model monitoring, the challenges you might face, and the best practices to keep your data science solutions effective and reliable. Let's begin by understanding why monitoring is not just a technical necessity but a business imperative, setting the stage for the rest of our journey. Once a model is deployed, its environment can change rapidly. Data distributions may shift, user behaviors evolve, and external factors can impact predictions. Monitoring helps detect these changes early, preventing performance degradation. It's not just about catching errors, it's about ensuring your model continues to deliver value. By consistently tracking key metrics, you can maintain trust in your data science solutions and respond proactively to issues before they escalate. This proactive approach is essential for long-term success in any data-driven organization. Effective model monitoring starts with identifying the right metrics. Common metrics include accuracy, precision, recall, and F1 score for classification models, or RMSE and MAE for regression models. However, it's also important to monitor business-specific KPIs that reflect the real-world impact of your model. By combining technical and business metrics, you gain a holistic view of model health. This ensures that your monitoring efforts align with organizational goals and deliver actionable insights. Data drift occurs when the statistical properties of input data change over time, potentially reducing model accuracy. This can happen due to seasonality, market trends, or changes in user behavior. Detecting data drift early is vital for maintaining model performance. Regularly comparing new data distributions to the original training data helps identify drift. When detected, you can investigate causes and decide whether retraining or other interventions are necessary. Concept drift refers to changes in the relationship between input data and target variables. Unlike data drift, which is about the input data itself, concept drift affects how the model interprets data to make predictions. For example, if customer preferences shift, a recommendation model may become less effective. Monitoring for concept drift involves tracking prediction errors and analyzing if the underlying patterns have changed. Addressing concept drift often requires updating or retraining your model. To effectively monitor models, it's important to establish automated monitoring pipelines. These pipelines collect, process, and analyze data in real time, providing timely alerts when anomalies are detected. Automation reduces manual effort and ensures consistency. By integrating monitoring pipelines with your deployment infrastructure, you can quickly identify and address issues, keeping your models running smoothly and efficiently. Robust alerting system is essential for timely responses to model issues. By configuring thresholds for key metrics, you can trigger notifications when performance drops or anomalies occur. These alerts can be sent via email, messaging platforms, or integrated dashboards. Effective notification systems ensure that the right people are informed quickly, enabling rapid investigation and resolution of problems. Comprehensive logging is a cornerstone of model monitoring. By recording predictions, input data, and system events, you create an audit trail that supports troubleshooting and compliance. Logs help you trace issues back to their source, understand model decisions, and demonstrate accountability. Maintaining detailed logs is especially important in regulated industries where transparency is required. Dashboards provide a visual overview of model performance, making it easy to track key metrics and trends over time. By centralizing information, dashboards enable teams to quickly assess model health and spot potential issues. Customizable dashboards can display technical metrics, business KPIs, and alert statuses, supporting informed decision-making and collaboration across teams. Monitoring reveals performance degradation. Retraining your model may be necessary. Retraining involves updating the model with new data to restore accuracy. Strategies include scheduled retraining at regular intervals or triggered retraining based on specific events such as detected drift. Choosing the right strategy depends on your use case, data availability, and business requirements. Just like software, models benefit from version control. Tracking model versions helps you manage updates, roll back to previous versions if issues arise, and maintain a clear history of changes. Version control systems can also store metadata, such as training data, hyperparameters, and performance metrics, supporting reproducibility and auditability. If a newly deployed model underperforms or causes issues, rolling back to a previous version can quickly restore stability. Rollback procedures should be well documented and tested to minimize downtime. By combining version control with automated deployment tools, you can streamline the rollback process and ensure business continuity. A/B testing allows you to compare different model versions in a controlled environment. By splitting traffic between models and measuring performance, you can make data-driven decisions about which version to deploy. A/B testing reduces risk and helps you optimize models based on real-world results rather than assumptions. Shadow deployment involves running a new model alongside the current production model without affecting users. This approach allows you to evaluate the new model's performance on real data, identify issues, and build confidence before full deployment. Shadow deployment is a safe way to test updates and minimize risk. Canary releases gradually roll out new models to a subset of users, allowing you to monitor performance and catch issues early. If the new model performs well, you can expand the rollout. If problems arise, you can halt or roll back the release. This approach balances innovation with stability, ensuring a smooth transition. In addition to model performance, it's important to monitor resource usage, such as CPU, memory, and storage. Resource constraints can impact model responsiveness and scalability. By tracking usage patterns, you can optimize infrastructure, prevent bottlenecks, and ensure a seamless user experience. Security and privacy are critical in model monitoring. Ensure that sensitive data is protected and that models are not vulnerable to attacks or data leaks. Regularly audit access controls, monitor for unusual activity, and comply with relevant regulations. Security monitoring helps maintain trust and safeguard your organization's reputation. Models can inadvertently introduce or amplify bias, leading to unfair outcomes. Monitoring for bias involves analyzing predictions across different groups and ensuring equitable treatment. Regular fairness audits and bias detection tools can help identify and address issues, supporting ethical and responsible AI deployment. Integrating model monitoring with continuous integration and continuous deployment, CI/CD pipelines streamlines updates and maintenance. Automated testing, deployment, and monitoring ensure that models are always up to date and performing well. This integration supports rapid innovation while maintaining quality and reliability. Effective model monitoring requires collaboration between data scientists, engineers, and business stakeholders. By sharing insights and responsibilities, teams can respond quickly to issues and continuously improve models. Open communication and shared dashboards foster a culture of accountability and innovation. Incorporating user feedback into your monitoring process helps identify real-world issues that automated systems might miss. Collecting feedback through surveys, support channels, or direct interactions provides valuable context for model performance. This feedback loop enables you to make targeted improvements and enhance user satisfaction. Automated retraining systems can detect when a model's performance drops and initiate retraining without manual intervention. This approach ensures that models stay current with evolving data and reduces the risk of prolonged underperformance. Automation also frees up valuable time for your data science team to focus on innovation. Scheduling regular maintenance for your models helps prevent unexpected issues. Maintenance tasks may include retraining, updating dependencies, and reviewing monitoring configurations. By planning ahead, you can minimize disruptions and ensure that your models remain robust and reliable over time. Thorough documentation supports effective monitoring and maintenance. Documenting model assumptions, data sources, monitoring metrics, and maintenance procedures ensures that knowledge is preserved and accessible. Good documentation also facilitates onboarding new team members and supports compliance requirements. Despite best efforts, models can fail due to unexpected data, system outages, or bugs. Having a clear incident response plan helps you address failures quickly and minimize impact. This plan should include steps for diagnosis, communication, rollback, and postmortem analysis to prevent future issues. As your organization grows, your monitoring systems must scale to handle more models, data, and users. Scalable architectures leverage cloud services, distributed processing, and automation to support increasing demands. Planning for scalability ensures that monitoring remains effective as your data science initiatives expand. Monitoring systems can incur significant costs, especially at scale. It's important to balance thorough monitoring with cost efficiency. Strategies include prioritizing critical metrics, optimizing data storage, and leveraging open-source tools. Regularly reviewing costs helps you maximize value without overspending. Many industries require compliance with regulations such as GDPR or HIPAA. Monitoring systems must support data privacy, auditability, and reporting. Regular compliance checks and documentation help you avoid legal risks and demonstrate responsible data science practices. There are many third-party tools available for model monitoring and maintenance. These tools offer features like automated alerts, dashboards, and integration with popular data science platforms. Choosing the right tool depends on your organization's needs, budget, and technical stack. For organizations with unique requirements, custom monitoring solutions may be necessary. Building tailored systems allows you to address specific needs, integrate with proprietary platforms, and implement advanced analytics. While custom solutions require more effort, they offer greater flexibility and control. Monitoring can be performed in real time or in batches, depending on your use case. Real-time monitoring provides immediate feedback and is ideal for critical applications. Batch monitoring analyzes data at scheduled intervals, which can be more cost-effective for less time-sensitive models. Choosing the right approach depends on your business needs and technical constraints. It's important to monitor not just model outputs but also inputs. Unexpected or invalid input data can cause errors or degrade performance. Input monitoring includes validating data formats, checking for missing values, and detecting outliers. This helps ensure that your models receive high-quality data at all times. Monitoring model outputs involves tracking prediction accuracy, error rates, and other performance metrics. By analyzing outputs, you can quickly identify issues such as drift, bias, or unexpected behavior. Output monitoring is essential for maintaining trust and delivering consistent results. Latency refers to the time it takes for a model to generate predictions. High latency can impact user experience and business processes. Monitoring latency helps you identify bottlenecks and optimize performance, ensuring that your models deliver timely results. Uptime monitoring ensures that your models are available and responsive when needed. Tracking uptime helps you detect outages, plan maintenance, and meet service level agreements. Reliable uptime is critical for business continuity and user satisfaction. Over time, models can become stale if they are not updated with new data. Stale models may lose relevance and accuracy. Monitoring for staleness involves tracking the age of training data and model versions, prompting updates when necessary to keep models fresh and effective. Models often rely on external libraries, APIs, or data sources. Monitoring these dependencies helps you detect changes or failures that could impact model performance. Keeping dependencies up to date and tracking their status is essential for maintaining robust and reliable solutions. Models can be targeted by adversarial attacks or exploited through vulnerabilities. Monitoring for exploitation involves tracking unusual patterns, failed authentication attempts, or suspicious input data. Proactive security measures help protect your models and maintain trust with users. Understanding how model changes affect users is key to successful deployment. Monitoring user impact involves tracking user engagement, satisfaction, and feedback after updates. This helps you measure the real-world value of your models and make informed decisions about future improvements. Overfitting occurs when a model performs well on training data but poorly on new data. Monitoring for overfitting involves comparing performance on training and validation datasets. Early detection allows you to adjust model complexity or retrain with more diverse data, ensuring better generalization. Underfitting happens when a model is too simple to capture underlying patterns in the data. Monitoring for underfitting involves tracking low accuracy on both training and validation sets. Addressing underfitting may require increasing model complexity or improving feature engineering. Model monitoring and maintenance are ongoing processes. By adopting a continuous improvement cycle, you can regularly assess performance, gather feedback, and implement enhancements. This iterative approach ensures that your data science solutions remain effective and aligned with evolving business needs. Empowering your team with the skills and knowledge to monitor and maintain models is essential. Training programs should cover monitoring tools, best practices, and incident response. Well-trained teams can quickly identify and resolve issues, ensuring the long-term success of your data science initiatives. The field of model monitoring is rapidly evolving. Emerging trends include the use of AI for automated monitoring, advanced anomaly detection, and greater integration with business intelligence tools. Staying informed about these trends helps you adopt new technologies and maintain a competitive edge. In summary, monitoring and maintaining models is a critical part of deploying and integrating data science solutions. By implementing robust monitoring systems, automating maintenance, and fostering collaboration, you can ensure that your models deliver consistent value. Remember, effective monitoring is not a one-time task but an ongoing commitment to excellence in data science.